Hello and welcome to my science show. In this first episode I'm going to be talking about the Mars Curiosity Rover. I'm going to tell you some interesting stuff about it, what it's doing on the planet and how it got there. But first, unfortunately, I've got to give a nod to some bad news that I'm sure you've all heard about by now. I hate to kick off the series with a dull topic, but it's one of the biggest losses to science in years. You'll already know, of course, that I'm talking about the death of Neil Armstrong, the first man to ever set foot on the moon, who sadly died on the 25th of August last week. He'd undergone some surgery on the 7th of August to correct a problem with his coronary arteries, but due to some complications from these procedures, he sadly passed away. Neil Armstrong's death has been rightly described as the loss of an American hero, not just of his time, but of all time. We've lost one of the bravest men to have ever lived. May he rest in peace. Thanks to Neil Armstrong and the success of the first missions to the moon and many other objectives, the space program has since flourished, and now we can celebrate the latest in space exploration, the Mars Curiosity mission. Curiosity is NASA's latest mission to explore the surface of Mars, as there have been a few before. It's been suspected for years that there is, or at least was once, life on the Red Planet, and scientists all over the world are determined to find out if there is. The mission will last a full Martian year, as that's as long as the rover's onboard nuclear power supply will keep it running. The idea is to scour the surface and take soil and rock samples, analyse them and find out if there is or ever has been an environment that could possibly support life in its most simple form, that being microbial. The microscopic life forms found all over Earth, such as bacteria, fungus and things like that. The rover we've sent to Mars is known as Curiosity. It's about the size of a car and we're able to run on the Martian surface unaided for around 687 days, or 1 Martian year. It's powered by a radioisotope system, which is a full video in itself, but essentially it generates power from the heat emitted as its plutonium power source decays. Curiosity will collect samples of rock and soil from the Martian surface, and so we don't need to find a way of getting them back to Earth, it will analyse them itself using its onboard science lab. To navigate the planet, the rover has to be commanded by the lovely people down at Mission Control at NASA. It communicates by relaying messages through the Mars Odyssey and Mars Reconnaissance orbiters, which then get bounced back to Earth and picked up by the Deep Space Network antennas. So that the scientists at Mission Control can see what's going on with the rover, it's been fitted with plenty of cameras and sensors to help the team plot its course. It's not as simple as a remote control car as such, as messages take about half an hour to get all the way from here to Mars and back, which, if it's discovered that the rover is careering towards the edge of a large ravine, is a little bit too long to tell it to stop. Instead, the rover is given a set of carefully planned instructions, which it then carries out over a set period of time. Therefore, the cameras on board provide the guidance team with invaluable data about the landscape. Curiosity is fitted with 4 pairs of HazCams, which, as you can tell by the name, are designed to help the team pick out any unexpected hazards in the rover's path. These cameras are mounted low down on the vehicle as to give a better perspective of how big the objects are. Then there are 2 pairs of NavCams, which are there to help navigate the rover. These are mounted on the vehicle's main mast, which provide an extra field of view for the guidance team. Both the Haz and NavCams are black and white, and as they come in pairs are also 3D, so the team has the best possible chance of seeing obstructions in the rover's path before they send it on its way. Next, there are 4 science cameras known as Mastcam, ChemCam and Marley. 2 of the 4 are paired together on the main mast, known as Mastcam, to give colour, high-resolution 3D images and video of the Martian surface. Mastcam also has a powerful zoom lens fitted, so it can see objects that are quite far away. ChemCam is where things start getting really cool. The rover is fitted with a high-powered laser that it uses to vaporise rocks on the surface. The plasma left behind from blasting the rocks will be analysed using an onboard spectrograph to determine the minerals and microstructures present in the rocks on the surface. The last of the cameras is the Mars Hand Lens Imager. This camera is mounted on the end of a robotic arm attached to Curiosity, which allows a close-up examination of rocks and debris on the surface. Finally is the Mars Descent Imager, or MARDI, which, as you guessed, was used to document the descent of the rover. Another cool feature of the rover, like just mentioned, is the robotic arm. It houses the Marley camera and a tool set of other sensors and gadgets. It has the ability to scrape away layers of rock and take samples for analysis in Curiosity's onboard science lab. It can also take microscopic images of the surface for analysis back here on Earth. The rover wouldn't be a rover as such without the ability to, well, rove. So it's been fitted with some clever suspension and wheels that would rival any ATV found here on Earth. It doesn't move very fast, so it's not going to go speeding around like a quad, but it does need to cross some pretty rough terrain and then climb a mountain. So good suspension and grippy tyres are a must. It's positioned atop what's known as the rocker bogie system. This system allows the rover to to be kept upright and keep the weight well distributed over all 6 of its wheels. The most interesting part of the rover's mission, and the most nerve-wracking for the scientists in mission control, I imagine, was the landing. The rover had to make a huge journey across space and then land in a target area on Mars that is just 93 by 12 miles across. However, it couldn't just impact the planet's surface, obviously, at the speed it was travelling through space, as this would have obviously resulted in a huge collision and loss of millions and millions of pounds. Once the payload reached the Martian atmosphere, the craft deployed a huge parachute, which slowed it down somewhat. As the atmosphere on Mars is quite thin, the craft still couldn't slow down to an acceptable landing speed, so further action was required. The shield, which had been sheltering the rover from the intense heat generated as it blasted through the Martian atmosphere, detached, and then the surface scanning radar was activated. Once the heat shield was clear, the parachute detached and the craft activated 4 rockets, which further slowed down its descent. If, however, the craft was to land on the surface by rocket power, the dust and debris thrown up could have damaged the rover. To combat this, the rover was lowered onto the surface from a hovering landing vehicle in a manoeuvre called sky crane. Once the rover was safely on the surface, the sky crane tether was detached, and then the lander accelerated away from Curiosity's landing site to then set down at a safe distance away from the rover. This is when the rover signalled to Earth and Twitter to inform of its safe arrival. So now the rover resides forever alone on Mars to take its 2-year mission and find the remnants of life on the red planet. Since its landing, it's had a software upgrade, seeing it no longer needs to know how to land. It's been packed with information better suited for the mission ahead, such as how to drive and how to use its robotic arm and sensors. One of the main updates was a patch to give it more autonomy whilst driving around the planet. The rover can now decipher obstacles on its own, which means less work for the guidance team and longer automated drives for the rover itself. The communication hasn't all been one way. Like any good relationship, it's nice to get some things back from what you put in. So the rover has been beaming back some Super HD pictures of the Martian surface, which are simply fascinating. To think these images have not only been beamed over millions of miles of space, they've been taken from another planet where nobody else has ever stepped foot. In this, one of the first high-res pictures to make it back to Earth, the rover has managed to capture a shot of Mount Sharp. It's 3-mile-high objective on the planet's surface that rises up out of the landing site, the Gale crater. It's an amazing thing, made only more amazing by the thought of all the variables and things that could have gone wrong that didn't. Curiosity is now safely sat on the Martian surface, millions of miles away, beaming us back data that will answer scientific questions and curiosities that span the centuries. If you want to find out a little bit more about Curiosity, why not head on over to NASA's website. There's a link in the description below, and make sure you subscribe to our channel, as we'll be updating you with all the latest news and progress with Curiosity in our news shows. Keep up to date with Deej on Science by liking us on Facebook and following us on Twitter, and don't forget you can ask us or tweet us your science questions or comment them below, and we'll answer them in the next couple of weeks. For now, that's all we've got time for. Thank you very much for watching, and I'll see you next week.